Okay, so it's 5 o'clock. We're gonna start officially recording right here. I've got this camera. I got a lot of different things going on here. So a couple things I wanted to bring to everyone's attention. A couple things I wanted to bring to everyone's attention, and hopefully everyone sees the screen, is that I posted some tutorials with exercise number 1 to maybe get you up to speed. I think some of you familiar with the processing and everything should be pretty set and pretty well to go with kind of what you're trying to do. Because remember, we're trying to automate processes, and today we're going to some of you are going to write your first program. We're going to talk about what a program is because we're going to be looking at a big paradigm shift, meaning we just use all these tools and we point and click, and then now you're going to be the one that figures out, all right, what are people going to want to point and click on? And I think sometimes I really want it to be a transformational day for some people. For other folks, like I just want to get done with this class and on the bigger better things, you know what I mean? And so, but for you can see this, you can see the video that I posted here because this is kind of what we're looking at here. This is what I look at in ArcGIS Pro, and I've kind of made this model here, and I'm going to kind of move it up here. So I went and made this model right here from the map that we were looking at, and you kind of put it into bigger and other things right here, where we converted this table to a text file to a table. And so those text files were just the number of text files that I downloaded from the Climate Prediction Center. Because what we were trying to do is create some sort of interpolation surface, create primary data, because most of the time in this class or a geostatistics class, I give you data and you do stuff to it. And we're getting to a point in time where you're going to be the one producing the data. Whether I was talking to someone out collecting like PM data or doing whatever, and you're going to have to figure out what to do with it if you're working with Dr. Yang or Dr. Bang and we're collecting all this different data out there. So we had this map right here where we collected these data for just this particular colleges and universities, and I didn't get this far with the interpolation surfaces, but I can click on my little model right here and I export this table. I turn it into a brand new feature class right here, and I do XY data to point, which basically means turn it from a table into some points on a map. And then we ran some sort of IDW. What's IDW stand for? Inverse distance weight. Okay, what's that mean? What do we use it for? Why would we use IDW?
Need the inverse distances between points.
Calculate the values. If I know the temperature there and there, how do I figure out what the temperature is right here if I don't know what it is?
Inverse distance.
Yeah, figure it out from everywhere around here. So the temperature stations that are closest are going to have more of an impact than those are furthest away. And we can do first, second, third order, where the ones twice as close are going to have 4 times more of an impact. Like we talked about with geostatistics. Remember we did that big fancy formula called weighted averages? Well, that's all it does, but just create this big gigantic weighted average, and it does thousands of times a second for us. IDW. So what we did here, we created a nice little kind of workflow so that we can create some of this Python code. And like I try to kind of tell people, is that I can go to export. I can go to this little button. I could export to a graphic. I could export to a Python table or this little window. So just by running this stuff here, I created this code right here that I can run. Now, some of the things about the code right here, you can kind of see what's going on. I say import toolbox, this little data management tools. I've got some input parameters because we're going to talk about what are the different input parameters that we can run. Okay, and then I got this export table. What do you think? The C::/ EASC 50. This is just where my file's sitting right there. And then this is where my file's sitting right here, and I'm writing it out to a geodatabase, and then I'm doing some more stuff right here. And so some of this stuff I really care about, but these are just all the input parameters that we're looking at here. Okay, one of the neat things that I kind of did was I opened up this tool and I ran something called Visual do a visual code here, and this is the actual code that runs everything. So we can get parameters and everything else. So I don't want to get too much into those there. I don't want to get too much into those there. Let me see what we got here.
I got it. My slash is backwards.
Oh, okay. All right. Yeah. Someone in the other class had that right there. And so we kind of looked at that right there. Now, when we click on this tool and we click right mouse, click open here, what are the things that it needs? It needs an input table and an output table. Okay. And so what do we need? That text file, it could be CS file or some of the other file formats that we worked with before. And we're going to export it to a Esri table that's stored within the confines of the geodatabase. So if you look at your databases, it's got the little gray cylinder. And so I put it from outside of the cylinder in the folder to inside the cylinder. Why would I do that? Those of you kind of worked with ArcGIS before.
Some legitimately you can use it to run the codes.
Yeah, I can use it to run the auto codes and everything, which is more fundamental to our ArcGIS and all that other good stuff is I've got a lat, I've got a long, I've got all these other things. A lot of times when we look at feature classes, what's the leftmost column have? When you look all the way to the left, what's the leftmost column have? ID, and usually call it like OID, object ID, which is going to be unique for each and every file. So a lot of times, Climate Prediction Center doesn't know or care about some sort of object ID, and now it does. So when I right mouse click on my colleges and universities, there better be an object ID here. Oh, there's not here because I kind of hit it. But when I go to Fields View right here and look at all the fields, you can see there's a little object ID right here that I can make visible. And so I've got a little object ID sitting right here, and it's got shapes and object ID that help kind of uniquely name it so that it goes between your map and your table, to create that unique one-to-one relationship so that each of these numbers are kind of unique between each other. And so what we've kind of done here is we created this model, converted its code, and this code just runs from the top to the bottom. A lot of neat stuff that we can do here. So hopefully when you did exercise 1 or you're in the process of doing exercise 1, we really want to figure out, all right, you had to run it 7 times or something like that for each day of the week, right?
8 times.
8 times? Now, hopefully some people, as we get further along, like, hey, we don't have to run it 8 times. Let's just change the name and we can load these file names into an array, or we can concatenate. Concatenate basically means add to the end, and we'll talk about what that word concatenate means today. We can just add to the file name and just do this once, 0 times, just click it once and run it. And so we'll look at some of those there today. Couple things I wanted to highlight. I put that up there. Also, I put all the papers that I've done in the past here. So any things that you're interested in, because I'll be posting like just tons of things about some upcoming GERS, graduate and undergraduate research symposium. So those are things that if you're interested in doing, do it. I've talked about those with our drone class because people want to look at cool stuff. You know, I'm going around and look at things. You know, people want to look at neat maps, look at neat imagery, look at whatever. And I think that's a really good opportunity for you to go and talk about research, especially all the PhD students we've kind of got here. Because I know Miss Powell sent that thing out, and I think students are getting voluntold to do that. Everyone knows what that means. Like, I would really love for you to do that. And students that are working with me and getting any funding from me are going to be voluntold to go and do it because we need some deliverables. But you can see some of the papers that we've done in the past here. And so, like I've talked about before, we've kind of started to look at find your go-to tool that we're looking at. This is a paper that we just had kind of published like 2 weeks ago, like this year, recently here. And so this is a comparison of raster point density calculator. This is really long, but when we talk about study the food environment, study of food access or whatever, we can kind of, instead of the word food, we can put things like healthcare, parks, and you start to notice a difference between all of these things, even though they're the same. Like things that are closer to you versus things that are farther away. And so when we look at disadvantaged neighborhoods, they're what are going to be closer to? Crime, point source pollution, poor water quality, and then look at the other end where that green space, greenways. I live in North Greensboro, and I can snap my fingers and I could be at the greenway just like that. It's really close, and I got lots of parks around me and everything like that, and healthy food. But how are those things going to measure long-term health impacts? So when I use the word how far away, how close, how do you measure how close? How would you measure how close is something away? How close?
Your means of transportation.
Your means of transportation.
Walking, driving.
Yeah, walking, driving. How do I quantitatively, and in this class, and especially with me, how do I quantitatively measure how close something is? Give me a number. 18 what? 18 miles. Drive time. Euclidean distance. Okay, what's Euclidean distance mean? Straight line distance. What's the advantages of straight line distance? What's that?
Less interaction.
Less interaction. Really easy to calculate, right? We just use our distance formula. Remember the square root of delta x squared plus delta y squared? Does that ring a bell? I don't want people to start twitching or anything like that, okay? But it's just real easy to calculate, especially when projected data. As opposed to what? In reality, we care about drive time. I want to spend as little time in the car as possible with my kids fighting. That's all I want to do. That's it. Okay? So we got drive distance, we got drive time, which are related to each other, but different calculations. How do you calculate drive time? Has anyone calculated like drive time between two places? We do this all the time here. And we just type it in. Now, who wants to do this thousands of times? I don't want to do that. And so we can do this within the confines of a GI. But what we talked about here was what are all the different ways that we can measure kind of accessibility, availability. And in this case, we were looking specifically at dollar stores. Okay. And one of the things we've seen in this study area, which is kind of in between here and Greensboro, it's like a 6-county area, is that these dollar stores were popping up. What is one other thing about dollar stores? They're cheap. Where do they pop up? Rural areas. But why? Do people like dollar stores?
Yeah.
I go to my little Nextdoor app and people complain about the dollar stores. Like, we got a dollar store coming in. What are we going to do about it? It's like, oh no, I'd rather spend, half the price for paper towels than I do across the street at Lowe's. Now, I live kind of in a rural area, relatively rural. So a lot of times there's some connotations with dollar stores and poverty and economics that I think some communities don't want to see, but my wallet is going to like it a lot. My wallet's going to like it a lot, especially when I'm driving home tonight and my wife needs me to pick up something. And one of the things that dollar stores have done, and I think more specifically on Dollar General, just because those have been proliferated a little more where I live, is they've got like milk, bananas, apples, all that other store. They got like groceries, got a little grocery section right there. And so what we did was we kind of looked at this particular area in terms of access to dollar stores, but it could be anything. Fresh food, healthy food. What is healthy food? How do we measure healthy food? Where's healthy food? Food line? Is that healthy food?
It was organic.
Organic, who's going to go and who's going to go out and figure out those healthy foods versus non-healthy foods versus fast foods? Well, Subway's fast food, but it's healthy, but who's going to go kind of do those? Fresh food, not me. I'm going to let I'm going to let Benjamin go and figure out all that stuff for him.
Dollar Tree in East Durham does not have produce, by the way.
Okay. Dollar Tree, not necessarily. Green. Yeah, Dollar General, no, but the one around the corner from my house does, yeah. It's got milk and it's got eggs and all that others. The bananas and fruit cost a little more than Food Line and Walmart, but less than the Lowe's supermarket, which it's built right across the street from. So basically what we did was we talked about all the different ways. Actually, this is a picture from the Dollar General across the street from my house, one of our rental houses that we have where we used to live. So I thought that was kind of interesting here. But we talked about how do we kind of measure these, and we did a little survey of all some of the different ways that we can measure because they can be measured by densities, like what is the total within my zip code? And I think in this case, we were looking at block groups, the total number of supermarkets per population. That's one way. So in this tract is 3.2 grocery stores per square mile, 4.2, 4.7. Another one we did drive time. How do you measure drive time? Where do we measure drive time from? Am I going to measure from my house to the nearest grocery store, then my neighbor's house to the nearest grocery store, and every house there? It's hard, huh? That's a lot of calculations. That's hundreds of thousands of calculations. Literally hundreds of millions of calculations. So how are we going to do this? And so we did looked at something called a centroid. What's a centroid? I'm kind of looking at the geostats people. Looking at that. What's a centroid? What's a population weighted centroid? You missed that lesson, huh? It's the center of population. Center of population. So instead of, for a zip code, if we've got 20,000 homes and me averaging the drive time to the nearest supermarket, which may or may not be different, I just do it from the centroid where most people live. It might be in the southern, northern part or whatever. And if we calculate those relatively easily, we did some Euclidean distance calculations, stored density by population. And then what we did, we tried to kind of compare these things, and we use this cool tool called the Jacquard index. It says, how much do they line up with each other? And then we ran something here called the join count, which just uses something called the spatial join. And I think most of us who've taken GIS before and like week 1 of geostats, you learned about the spatial join, right? You looked at a big map of cancer death and you had to count them all by county or zip code or whatever I had to do because we don't want to look at all the deaths. We won't just want to count them by county. And so we did this join count, but when we run these join counts, there's a lot less granularity. This is a big fancy word for just saying, what are the possible values you could have? 0, 1, 2, 3, or 4. That's the only possible values. Where that if we're looking at drive time, it could be 7.3, 9.7, 14.3. We have a lot more granularity that we have. And so you might look at some type of, with these join counts, some type of like logistic regression. Let me see if I'm kind of nodding their head a little bit there. Logistic regression. That's okay. You can look the other way, where we got something or nothing. It's the curve on it is slightly different or whatever. But we did something called Jacquard index that kind of compares us. So we got a couple of these papers up here because I wanted to highlight some of the stuff that we're kind of doing, because at the end of the day, we made a map that looks like this. It's kind of this density map right here. And we just grouped them by units like block groups that have population, income, race, ethnicity, education, all those attached to those, so we can kind of do some bigger and better work with those. And so we can make maps that look like this. Why did I put dots outside? Or what the person who made the map, why are they including dots outside of the study area? That kind of looks kind of silly. What was the last thing we talked about in geostats? Why are we including points out here, even though they're not in the study area? This is the very last, the geostats class. Remember that?
They're outliers.
The outliers. What about the outliers? What are you going to say?
They're kind of on their own.
Kind of on their own. All right, on the right track. What about the idea of edge effects? What's the edge effects mean? I mean, I'm living right here. Okay, if I live right here, I might go here to a Dollar General instead of driving all the way over here. So these points right here actually impact my study area because they're part of my density calculation. Okay, we don't live on an island. Right? So the things, the things, or I don't want to use the word things, but the dollar stores outside are gonna have an impact on the density inside. And so if I were just to run the density for everything within, it's gonna look slightly different. And then we kind of turned them into some other maps right here, because when we look at things like point density versus 3 mile buffers, how many are within 3 miles? Versus drive time versus Euclidean distance versus store density. These are like all the different ways that we can measure availability. So when I say, like, what is the availability of fresh food or parks or healthcare? What are some of the things that you see these days in this day and age in research where there's disproportionate access for? What do we see about in the news? Like, even like voting, like, do people have access to like voting polls?
Stations.
What's that?
It's like I was saying, yeah, voting station.
Yeah, voting stations is another one.
Central has one, so we come here.
Yeah,
To
like-
make sure it stays open.
Yeah, we have or I guess we're supposed to have an election coming up. So, but voting, healthcare, mental health services, okay, a lot of these things that we can make maps, substitute the word dollar store for any one of these, and we've got a whole line of research sitting right here, ready to go that we can look at. Now, who's going to go create, or gas stations? Okay. Well, who's going to create the data? Where did we get the dollar store from? Did I send Chima out and drive around this whole area and start collecting dollar store data? No, he would have been real mad. He wouldn't like that. Well, I kind of kid on Chima because he does anything and everything. He's kind of our kind of jack of all trades there. But we have a database of all the stores in the United States, and they're given something called an SIC or a NAICS code, standard industry code, or North American Industry Classification Standard. We just did it, and I also have the store name. So I just said find everything that's Dollar Tree, Dollar General, or what's Family Dollar. That's the other one, Family Dollar. And I don't think Family Dollar typically has groceries. Our Dollar Tree has a little bit of milk and like frozen pizza and things like that. But our Dollar General up where we are has fresh food. So we queried out these because, as you can imagine, you look at this, how many businesses are in these areas here? Tens of thousands of them. So we got to query these things out. Can you query data? You bet. We've done that. Okay, you took Geostats, we did this. We showed up last week. Hey, let's find everything where it's within 50 miles of the border or whatever. So we've got the location queries, and we've got the spatial queries. The last thing I'm going to talk about here is I'll talk about a couple more things here because they get into the data science part of things a little bit. But we're looking at geospatial relationships between female breast cancer mortality rates and environmental socioeconomic indicators for North Carolina. And this is Elena Burwell. She was a recent PhD student. She came to me like a year ago, or one of her advisors, like, I need some research topics, because she was doing some wet bench stuff. And she wanted to kind of put some of these together. And I think she was a little kind of flustered about some things here. And she wanted to look at the relationships between African-American female breast cancer death rates versus others, and then look at socioeconomic associations between breast cancer deaths and some of the other socioeconomics that we can collect, because within each block group, we've got income, we've got race, we've got education, we've got all these other things in addition to some of the measures that we can look up, like distance to health care, access to transportation, some of the things that we can derive that we did for some of these things. And you can see what we did here. And what we did was we went to the site called the, not Climate Prediction Center, but Vital Statistics Database. And we extracted out the data for every single person who died in North Carolina over a yearly basis. That's the database we're talking about with Cameron, where he's looking at mapping suicide in North Carolina. So what she did was she went and kind of extracted these from 2020 all the way back to 2003. So we put together that big Excel spreadsheet, and we just kept putting it together and together and together. Cameron's been doing it for the last 5 years, 4 years.
I've been doing it for the last like week.
Okay, no, 4 years,
Yes.
4 years worth of data. He's been doing it for a week, but 4 years worth of data or 5 years worth of data. Why is he getting 5 years? Why don't he just work with 1 year? We want to see a spread because a lot of times in 1 year we might have 1,000 suicides. You know, we got 700 zip codes, so we're looking at like 0, 1, 2, 3. We look at them a longer time so we can get a better idea of the rates. So remember we talked about that small number problem before? You know, if we went from 1 suicide to 2 suicides or 1 death to 2, that's could be happenstance, but if we went from 50 to 100, that would be some sort of problem. And so we looked at this here. Now we saw an increase in the frequency, but that wasn't that big of a deal because the population of North Carolina was increasing. And then she did some 3-year averages and then some rates here. So you can see it kind of teased these out a little bit. And we went and kind of did something called age grading because we made some nice, pretty maps. And this is the map that she made here of age graded mortality rates right here. These are the mortality rates. These are the age-graded mortality rates. So these are mortality rates in North Carolina. What do you know about these areas that are darkest? Rural. Also, especially out here, lots of old people out here. So you're kind of like, well, we're just kind of mapping the rural and the old people, you know, and old people. What ages of people tend to die at higher rates than others? Old people. Okay, older. And so we can normalize by population and then what kind of remains? That rural over here. And so this was a big practice in data science because making the maps took like a day. Putting the data together, that took a couple of weeks. 20 years worth of data, extracting out cancer rates, really researching some of these things here. It gets into some bigger questions in terms of, do we want to just extract out the people born in North Carolina? Why wouldn't we want to keep all the people born outside of North Carolina? Is it difficult to manage? Because if you die in North Carolina, you die in here, you know, it's going to have your record. It's just noted that you were born out of state. But where do you get cancer from? Do you just one day show up with cancer? No. What's that? You came to North Carolina or whatever. It might be something health, it's you know, obviously, you know, genetics or whatever, but exposure to water, air, bad food, whatever things that take place over long periods of time. So whatever you're being exposed to in Michigan or whatever surely shouldn't impact us or do whatever that we have here. So we created this. And then we created a nice little cluster map right here. So like you said before, that northeast portion of North Carolina. And then we ran a nice trusty two-tailed t-test. So most of my papers you're going to see have a nice two-tailed t-test where that I say, hey, let's look at the race in these red areas versus the race in the blue areas. Or the percent white, percent African American, percent Hispanic. Those are things that are collectible by the census. Let's look at the income in the red versus the income in the blue. Let's look at access to transportation. Let's look at all these things together to see if there's a difference between those. And she definitely did see some differences between those. And so we can look at the quantiles. We can look at the block groups. You can see just in the, you know, just in the mortality rates, it's $40,000 versus $46,000. Those hot spots of cancer mortality had $6,000 less per year. They made $6,000 less per year. What are the statistical chances that you just grab, you know, 50 block groups and versus another 50 block groups and they happen to be $6,000 difference? Not very, we could say, you know, less than, you know, 95% sure, you know. So those will be some of the things that we kind of get into here. I got those, and then this is kind of my favorite paper here, where Dr. McGinn and I kind of want to look at the relationship between COVID-19 by mail. Once again, a nice little two-tailed t-test. You know, this paper here was 3,000 word limit, so 3,000 words, that goes real quick. But the one thing about this paper was that we had to go and find the percentage of people who voted by mail in the 2020 general election. And we were just given a list from the North Carolina voter statistics database that just had a big text file of all 5 million people and how they voted. And like I said before, Excel is not going to like it, pure Excel. So we can run some things called query editors. I think I tried to bring it into ArcGIS Pro because I like doing stuff in ArcGIS Pro and query everything out. And so this would turn from like 5 million records into a nice pretty map using some things called summarize and select by location and these joins to make these nice pretty maps so that we could see association. So we could see clusters where by mail voting was higher. Why might by mail voting be lower? People who literally send in their ballot never show up. I showed up early, like on a Tuesday or something like that. People who never show up at the polling place. What do you think might be going on in these areas in northeastern part of North Carolina where by mail was lower? They might not have had like by mail or the resources to provide people. So like we talked before about some of this disproportionate access, those are some things that can really bleed into all parts of your research. All right. So today we're basically going to start writing tiny little programs here, and we're going to do a really big paradigm shift where that when we ran this tool, okay, we ran this export table here, and I'll kind of leave this for you folks looking here. We've got input. When I wanted to export the table, what was the input? I run IDW. What's the input for IDW?
The output from your
Yeah, output from just a bunch of points, right? You want a bunch of points. Okay, that's the input. What's the output going to be? It's going to be a surface that you create. And we can change all the environments or whatever we want, and like the mask and the processing extent. We won't worry too much about those. Okay, and then in between we run a bunch of stuff. So today we're going to talk about programs so that we can write a bunch of stuff. And today we're going to look at something called Small Basic. It's a little nostalgic for me because my dad is a programmer. He started with this language called C back in the 70s. And I learned on Basic. And so they've created this little programming language called Small Basic where we're going to write tiny little programs. And I've got a short little presentation, and then we're going to start writing some programs here. And I'm kind of excited about it because eventually we're going to get to a point in time where instead of input where you type something in, hey, we're going to specify that the input is going to be a feature class. Just like Chima said before, what's the input for IDW? A feature class of points, and the output's going to be a raster. Now, we don't have to program any of that stuff because Python takes care of us really well here. And so we're just going to kind of fill in the missing code because when we write programming for Small Basic, and we're all going to write our very first program today, some of this might be very rudimentary for a lot of us here, but computers are used for different purposes in different situations. They can be versatile, they can be programmed, because eventually what we want to do is automate processes. Do you want to go and hunt and peck and find all those buttons, or you just want to create this model and run the same thing over and over again? I know what I want to do. I just want to create the same thing so it can run over and over again, and I can change my input parameters because the more you have to type or the more you have to click, the more you're going to screw up. So a program is going to be a set of instructions that tells the computer what to do, and it cannot do anything unless it has a program to tell it what to do. And so like you've heard me in GIS class before, computers and ArcGIS Pro, they're really stupid. Why? What do? Whatever you tell it to do. And so if you tell it to do the wrong thing, it'll do the wrong thing. And so we're going to talk about some of this instructions here between input and output, all the stuff here. And the way that we write it is what we call syntax. Meaning, all right, this program understands something while this program doesn't understand something. And so they're used to operate the components of a computer. Can I calculate the hypotenuse of a right triangle if I know the two other sides? Of course I can. Okay, square root of a squared plus b squared equals c squared. C squared, square root of a squared plus b squared equals c squared. Yes, that. What's that called? Pythagorean theorem, something like that. Kind of based off the law of cosine. Yeah, law of cosines. Can I calculate my speed if I know the distance traveled? Yeah, of course. Distance equals rate times time. So if I know the time and I know the rate, I can calculate the distance. So this program, there's no one way to create a program or write it. And like I'll kind of tell everyone here is, I'm not a programmer. I just like writing I want to write programs so that I can simplify the things that I need to do. Okay, so we're going to look at things like metadata automation. And we're going to pull from all the metadata here because I don't want to go point and click on all the metadata files within a database. And so it's a lot more of an art and science. And so those of you who are different side brain than science, I think there's going to be a really good place here. We're going to learn the art and science of programming. Okay, we're going to run these within hardware, software, our actual computer's hardware. We don't have to worry about processing speed because this application we're working with is called BASIC. It's called Small Basic. And what we're going to do is we're going to open it up. We're going to open up a couple programs today and talk about those. But each thing has a processing unit, memory, input devices. Because today we're just going to write programs where you take in two numbers, you add them together, and you display the output. Eventually, we'll get to a point in time where, hey, you take in a feature class and an attribute, and you see if it's null or not, and then you count the number of times it's null, and then you just tell the user how many times it was null. Now, I could do that pretty easily, but you want to do it for 800,000 records? Oh. Okay. And then we have output. And so with Small Basic, for the most part, what we're going to be working with is just you write a program and we type something in, it gives us a little bit of output. So we got the CPU. This isn't that big of a deal because we're running really small programs. Okay, we're not going to worry too much about those. We got the memory. We're not going to run out of memory. Now, if I'm calculating like 200,000 addresses on my desktop computer, I'm going to run out of memory really quickly. Okay, that gets ugly quickly because when I calculate my drive time, how many calculations am I doing? I want to go home today. I want to go home. Okay, I want to drive home, and what happens here? How long is it? How many calculations is it actually doing? Just one? It's doing a lot. It's going to say, hey, you got traffic, or you got this, or you got that, or whatever. Okay. And so we've got bits, we've got bytes. I don't want to kind of worry too much about this stuff here. We've got different storage right here. We've got our hard drive, our disk drive. We've got floppy disks, CD-ROMs, USBs. I like storing stuff here, but in this day and age, we've kind of got these clouds which have dedicated URLs, HTTP, something that's going to be unique for all of my zip codes and counties and all the stuff we started to add last week. Okay, so whatever we want. Our input, for the most part, what we're going to be doing, working with today, is just keyboard. You type in a number. I want to convert meters to feet or feet to meters. We're going to type it in. And so we can also put in a mouse, scanner, digital camera, feature classes, maps. Okay, whatever we want. Now, when we work with Python, especially when it integrates with ArcGIS Pro, it gives you, hey, what do you want to input? We want to input a feature class. I click on that little feature class, and then you figure out what you want to do with the feature class using your 10 lines of Python code or USB. We've got output. For the most part, we're just going to output stuff to the monitor. Our printer, our disk drive, our USB, and then the software. We got the operating system, application. This software that we have is really, really easy. It's been installed on all these computers in here. You can install it on your home computer. So hopefully those people joining us are able to do that. Because what we want to do here is that we want to define the problem. Okay, make sure you understand what the program should do. Like I said, we're taking a really big, what I call paradigm shift, where that I'm using the IDW tool. Now you're going to be the one writing the tool to figure out what people like me want to do. Okay, so how should the user be able to enter? Programs come up with one answer. How many different answers? Because we're going to kind of hit some math. We're going to talk about the quadratic formula. I'm kind of looking and see who's looking away here. Quadratic formula. Who remembers that? Andy, you remember
That
that?
the x is equal to, oh, go ahead.
What do you say, Andy? Remember that? Barely. Oh, okay. The negative b plus or minus square root of b squared minus 4ac all over 2a. It's a lot. Is that what you're going to say, Marlene?
Yes, I know a song to it though. It's like the
Oh, good.
Pop Goes the Weasel.
Up goes the weasel. Oh, that's pretty funny. Mhm. So we can analyze the problem. We've got the user, and now what we've done is basically you're gonna be, instead of you being the end user, okay, you're gonna be the user and you're gonna be the programmer. Okay, so we got to figure out how these things are gonna work. What are gonna be the sequence of steps, and then we've got to kind of worry about all what is gonna be good input. Here's one here. Who remembers this problem? We want to predict weight using height. Weight equals 3.966783 times height minus 124.691. Who remembers that? Anyone remember this little formula here? Ariel's not looking at me at all. No. Who remembers this little formula? This is from Geostats. Now, what were we doing? We were doing just really simple linear regression, right? We're doing lines of best fit, where we just said, according to the World Health Organization, so someone who's 56 inches tall would be 90, should be, or whatever it is, 50 and 97.8. That number, 58 equals 105 pounds, so forth and so on. So we want to write an algorithm to solve this problem. What do we need to do? We want to, all right, you type in a what? Type in a height, it's going to multiply times 3.69, subtract the 124 from it, and then output the weight. And we've got a couple of programs here that we're going to work on in class, and then we'll start looking at the homework too. So we've got this input. You type in the height. We do a bunch of stuff right here using syntax. That means what this program can understand, because Python's going to understand something different from C, from small basic, and whatever, and then we're going to output something. So the input's going to be what you type in, output's going to be some type of weight, and then we got do this processing and then output. So we got to develop another algorithm here, because really is 3 steps enough. If I go and type in my name, what's it going to say? What is 3.94 times my name equal to? And what's Daisy? What's that face mean? That's pretty weird. I don't know what it means. We're working with different data. So what are some things we need to think about? All right, we got to make sure this thing's a number first, and then we run. And so a lot of times with those drop downs right there, especially when we looked at Python with IDW, it said, hey, I'm only taking feature classes. If you navigate to a text file, you navigate to a layer, one, it's not going to let you see it, first of all, right? Okay. Or 2, it's going to say, I can't run this thing, especially when you go to like Excel and you try to open up a Word document in Excel. What's that do? I don't know what it looks like. It's ugly, because you can click on all files or whatever and garbage, it ends up being garbage. So we need to kind of we need to validate numbers. So what we need to do is, all right, let's read in the input. Let's type in a number. Let's make sure the number is actually a number so that we can go through and do the calculation and output it. Okay. And so we keep kind of working with these things here. So I want to make sure the height is a positive number too. What if you type in a negative number? You can't have negative height. And then we multiply the height times this number, we subtract from it, and then we just reply with the output. And so we have things like write, and we write to different output parameters or whatever. And then we start to create flow charts and hierarchy charts and what we call pseudocode and those flow lines. Does these things kind of ring a bell? These little arrows? Yeah. All right, this is what Model Builder gives us here. So you can export that graphic or image and it'll give us something. And then here we make a decision. Hey, do we have to go back? Did you type in the wrong number? Or are you just going to end the program? Like, if you don't type in a number, you shouldn't deserve to run my program. Go away. Or we're going to go back and run these things over and over again. So when we start just writing this really simple program, you're going to write a program so someone can calculate their weight based on their height. We're going to read in the weight. Is the height a positive number? No. Display the error message. Go back again. And then next, we're going to set up a variable name called weight. In math class, what would be examples of variables? A, B, C, D. My class, my algebra teacher, they called them X and Y, right? X and Y. Okay, well, I don't want to call them X and Y. I'll call this thing weight and height, because I know what weight and height are. You know, I can call it X and Y, but guess what? I'm going to have to go back later and type out what it means. Display weight and end. So we can write the code. We use small basic. There's other programming languages, Java, C, Python. The thing about Python is that it's the scripting language for ArcGIS Pro, meaning it's got all like the ArcGIS Pro commands ready to go right there. They know what they mean. They know what IDW means. So all you need to do is just put the input parameters and it'll generate code for us. So these are some of the things that we can do. So we can debug it, we can test it. An error is called a bug, so debugging is getting rid of errors. And the one thing about this class that I want people to take from is that it's really easy to like write stuff that runs all the time. It gets really tricky to do what? Figure out when stuff goes wrong. I kind of equate it to like my wife when I met her, like we could go on cruise, we could have a good time, but what's going to happen when someone loses their job? That's when you really see, oh, I run this programming code, and what's going to happen when, hey, line 23 doesn't work, line 1000 doesn't work. You're like, I got to go to line 1000 and figure out everything's wrong. That's where kind of the rubber meets the road. Okay, and that's where you kind of really earn your, earn your rewards or whatever for being a programmer. Because to me, there's lots of tools out there. We got PyCharm, we got lots of other. I've been getting into this Visual Studio that I've installed on the software, and then we got the IDLE called Integrated Development Learning Environment. But that's where you earn everything when you start to make stuff that's wrong and make it right. That's real tough, and that's what people want. People want programmers. They want problem solvers. Can you solve problems? That's what we all want. And like we do in this, like I want in this class, I want you all to be better than me, something. If you kind of looked at my bio, I know a little bit about a lot of stuff, but I don't know anything, a whole lot of anything really in depth, because there's so much the GIS, and I just like to pretend I know what I'm talking about. So we also document the things, okay? Document it. So we can put little hashtags or parentheses or whatever up there that says, hey, this is what I'm doing with the code. So when you turn it in next week, you can show me what we're doing. So we can do external documentation, or we can do internal documentation, which are basically called comments. So in Small Basic, what we're going to do is we're going to put little comments saying, hey, I'm asking for the height. I'm asking for the weight. Okay, and now I'm printing everything out. And so we're going to do those because we have things called text windows.write, text windows.read. Okay, text window is just going to be the window that we write to. And then text window read numbers, what? We read numbers, so we don't even have to worry about, we just got to make sure it's positive or negative. And so we can kind of look at if statements with those, and I think we get to those conditionals later. So what I want us to do today is we're going to go to we're going to go down and we're going to write our first program, but we're going to type in the word small basic. Small basic. Yeah, I want to make sure everyone opens this up right here. Small basic. You don't have it? You have ArcGIS Pro on that thing?
Yeah, I do.
Where is my little, this is mine. Where is it?
So I went and installed it.
All right, does everyone see small basic? So go down to the bottom, type in the word small basic. And Cameron, I'm looking for where I put small basic.
Go down to the bottom.
Go down the bottom right there, type in the word small,
Go
S-A-N.
down here. Thank you.
She doesn't have it installed. Did anyone have it installed? I know it's installed on that.
This,
Yes. Okay, and I've got it downloadable. I've got like a flash drive just laying around right here that what did I do?
But I don't, this with a desktop and something anyway.
it's,
What?
So.
Oh. I found that as the.
Why don't they put it online? It's right there.
Another admin. Oh, here we go. This is what we got right here. This is that right here.
Different thing?
Alright. Downloads for. If we wanna go and download it, cause I'm kinda frustrated that it wasn't installed on every computer here. In order to download, it's under small basic resources. Click on this, oh. Shoot. Where's the down? Okay, yes, this is small basic. It's a really small program. I wanna make sure everyone's able to install it on their computer. Okay, if you know I've got the password, just download that thing. You got it, Andy, here? Didn't I already put it up here?
I don't know. Maybe I didn't just go through my, it's not central.
It's even downloaded.
Where are my modules? If he went under what?
You got an Oreo back there? Working on it? Down. This, you got it open, right?
Yeah, it's on the computer. I was gonna put it on here so I can work with it. But I can do that by the time.
Okay. You got it installed back?
It's supposed to write small thing.
Try.
That's right.
Those of you up there, we're trying to get everyone installed here. Is there a way that I can install this without? Install this, it goes here.
Yeah.
Where I've been trained.
Oh.
We'll install it using this one and then we'll just sign back in using the others. You gotta install stuff here. Oh. What if it's been installed for this user? So it's here. There it is. We run it here. You can run it from that other one. Okay. It doesn't like the others. Didn't install that in the store. I signed in as the other one. Here it is. Yeah. All right, yes. They only installed this. They only installed this.
Yeah, I mean, I think we can do that.
Sort of go to your, yeah, my URL and download it. Okay, so we're gonna write our first program here. No, I thought we were installing. Why is that?
Did you download?
Basically, July was gonna add in, so we could run it.
Some just have to go. Real small basics, what I do is.
Okay, now.
Baby stuff.
Yeah.
So we're watching from home.
Okay. All right, so what we've got going on here is what we've got here is, this is where we're gonna write our programs that we can store. They're gonna store it using the PostScript called .sb, but we're gonna write our first program, and usually they're called Hello World. And so if we go to our tutorials, we can find a lot of things here, but this is gonna be our first program. We're gonna type in text window. Text window. Now, what pops up when you see text window? The text window provides text-related input and output functionality. So this is going to be a command that we're going to write. Okay, and then I type a little right dot. And then what can I change here? Right line, background color, clear, cursor left, cursor top, whatever I want. And I'm going to type in the word right. And in parentheses, I'm just going to type in the word hello world. Okay. Now, where do you see these parentheses from? This is from math class. What are those things that you take in math class in parentheses? What are those called? F of x equals 2x plus 3. What is x called? What's that? functions, and then that X is called an input parameter. That's what it needs to run. Did we use the word input parameters already? Exactly. Now this time, what do we tell it? We're just telling it to print hello world instead of a feature class or set of points or whatever we're gonna do right here. Okay? So I've got a one-line program right here. I can do new, open, save as, import, publish, paste. This is really kind of pretty rudimentary. And I put it in quotes. Why did I put it in quotes? What's that mean? Why is it in parentheses? Or why do I have little quotes there? What are the different types of data out there? We got strings, we got text, we got numbers, we got floats, all that other stuff that we've talked about before. And then we get more complex when we work with Python. We will look at attributes, feature classes, points, databases, everything else. And I'm going to hit the word run. And then what happens? What'd you just do? Hit the word run. Hit run up there. What'd you just do? Hit run. Okay. What did it do? Hit run. Oh, you gotta type in that stuff up there. Gotta type in text window.
Should this be a comma or a period? Should that be a period or a comma because it's.
Dot. Dot.
Okay.
And then click on the right there. You already have it right there. And that's fine. Now, click run.
Okay. Yeah, it's a comma.
Now, what's it say?
Hello world.
What's that thing? Partitioning.
Yeah, but it's not finished.
Yep, that's the program. What'd you do? What's going on with Ario here? What are you?
This window right.
It's just.
My AOL and download it from my site. So what do we have here? It says, hello world, press any key to continue, which basically means this thing is called the text window. There's only a few places where you can input and output on ArcGIS Pro, on Small Basic. And so we'll look at a couple of those next time here, okay? So we've got some right here, okay? Next thing we want to do, okay? Next thing we want to do, and if I really wanted to, I could put a colon right there and a couple of spaces, and what's going to happen? I run it again with a colon and a couple of spaces. What happens? You see the colon and a couple of spaces that I've added. So this is really, I'm really trying to frame what people have. Now, what's the input parameters? The stuff that I've hardwired into you typing in. Next, what do I want to do next? Well, what do you want to do next? We want to ask someone to type something in and add two numbers together. Okay. Let's add two numbers together. Okay. So let's see what we have here. Text window. Dot. What are all the things that I have in here, right here? Read number. What's read number do? Reads a number from a text window. It will not return until the user hits enter. What do I want to do? I want a program that does what? I want a program, read number, okay? And you're gonna type in one number, type in another number. Okay. So text number dot read window. Now we got to give it a variable name. What do we want to call it? In Matplotlib, we call them X and Y. What is the first number that we want to call it? What will be the variable name? What's that?
We're going for like height.
Well, just two numbers. Well, I'm doing a little calculator. I'm gonna write a little program where you type in two numbers and it's gonna add them up for you. We'll get to the height thing in a second. I think I did one with meters or something like that, so. Okay, so we'll call this thing num1 equals text window dot read number. What do you think that's gonna do? We're gonna create a variable called num1 that's gonna be reading the number. Now, so num1 equals text window dot read number. So we're gonna create a variable called num1. Now, what is Andy gonna type in? Or the user of Andy's program, what are they gonna type in?
They're gonna type in numbers.
What number are they gonna type in? I don't know either, you know, so if I type in 82, -3, 72.3, so it could be anything they type in. So it's a variable. The other thing that we have here is that equal to sign. That equal to sign, it's not commutative. Who remembers that commutative word back in math class?
Can't go front and backward.
It can't go backwards. This equal to sign means takes on the value of. So if I were to kind of switch that, it says num1 is going to take on the value of text window dot read number. Now where's text window? Text window is that little number that pops up. Okay. Do I need to write the number again? I'm gonna have another variable. What do you think I'm gonna call the second variable? Num2, exactly. Num2. No, not num4, num2. Num2. How about the sum of the numbers? I want to give that a variable name. What is that going to be? Sum. Okay, so I'm going to have a variable called sum. So sum equals num1 plus, look what happens now. When I start typing these in, it knows that, hey, there's a num1 and a num2 variable. Because if I type in the word read line, can I create a variable called read line? No, because it's going to say, hey, are we talking about the read line that, or read number that you have here, or are we talking about variables? Also, those of you in ArcGIS Pro, when we talk about variable names, file names, when we have things like number signs or ones, things that start with numbers, no. So I keep them really, really simple. Me, I like to use underscores or whatever else too. So num2, num2. And then what do I want to do here? The sum is sum. So what am I doing? I got 4 lines, simple 4-line program. Can you tell me in words what does the first line do? It asks the user to type in one number. Second one asks the user to type in the second number. The third line says, hey, I'm going to have a variable that's called sum, where we add the 2 up. And then what's the last one do? We just do hello world, but what are we doing? The sum is, and then I have a little plus sign there. What do you think that plus sign does? It concatenates. This big fancy word, we use concatenate. All it is just adding stuff to strings. So am I going to type the word sum there? Are you going to see the word sum, or are you going to see the variable name from num1 plus num2? You're going to see the variable name from num1 plus num2. Did you run it, Barbara? Okay, let's run this thing. We're writing our first programs here. All right, so I'm going to type in. Did you run it?
Did you run num?
Hit enter.
Plus, two.
Okay. Getting there, we're getting there, we're getting there. Getting there. Now, it's not, what does that mean?
What did you?
What's that little shaky face mean? No, I mean, like. You gotta type in the number, type in the number. One, is another one?
And then he goes into.
Three plus zero, whatever you have. Now, this. Don't put it, don't put it in there. You gotta run through it. Here.
Right, I'm gonna get there. It's in, do you have anything?
Oh.
That's mine.
So this is the last year.
Okay,
2016.
now, Mac ran into a good error here, meaning this is what Mac had. I don't wanna, point them out or anything, but what do I have here? Num1 minus, we don't know what that means. That's what we call a syntax error, meaning I don't know what that thing means. A lot of times if you're writing in like a different language in Word and you got all the red squigglies, you're like, it doesn't understand. You gotta change the language. And so we've got this. Now, was that program very intuitive? Did you know what to do? When that space popped up, what are you doing? Like, you start blinking here. So what are some things we can do? In that read number, what can we type in? Hey, let's type in number 1, please, if you may. And then what I'm going to do is just highlight it. Control C, Control V. Oops. I got an error. And let's not do read number. You know what we're going to do here? We'll just do a right here. There's a couple different ways we can do this here. Well, did you tell it?
No, what you just told.
All right, run it. So type in a number. Type in another number. Hit enter.
The money president.
Well, it tells you the president you to continue.
What's the number say? The sum.
The num one is,
Well, we don't want the num1. We want the sum, right?
so I need to take this one.
Yeah, we want the sum. All right, let's see what we've added here.
The sum. Let's see what that's.
Now let's run this thing here. Now, what do I got here? Type in the first num, and do you know now what to do with the little flashy thing there? Yeah, type in the first number. So these are our input here. Now, what am I gonna do here? I'm gonna put a little colon, little space, little colon, little space here.
So it's,
Uh-huh. Now, do you see what I've got here, Erica? Because is it intuitive that you have to type in a number on your program?
No, does
No.
it just tell me?
It just did, no, it doesn't. So now I've written a little program where I write a line that says, type in the first num, type in the second num.
And then I got a number. So,
Uh-huh. So now I'm gonna type in the first num, 56, 100. What should it be? My answer should be 156, okay? The sum is 156. Type in any number. Okay, did you get that, Barbara? All right, good. Now we've got, all right, let's start getting a little more complex here. All right, a little more complex here. How about the sum, watch this, of what's this? What did I just do here in my last line here? So my text window dot right says the sum of, and I'll kind of point everyone over here joining us virtually here. Now the last line I said the sum of num1, and I got to put my little plus sign here. Why? This means concatenate. So the sum of, I got a little space there. Why do I have a space after the word of? So I don't want them all squished together. So num1, num2. What's Dolores gonna type in when she runs it? Whatever she wants, right? It doesn't matter. And it's gonna be different than Andy, than different than Erica. So whatever num1 is that we went through the trouble of asking the user for, plus num2 is what's it say here? Uh-oh. Unexpected error. Expected expression here. Line 6, line 39. What am I missing here? How do I change this? Right down here it says 6 comma 39. Expected an expression here. What does this 6 comma 59 mean right here? Line 6, column 59. So now I'm going to go over to 39. What am I missing? What should be there? What did I do wrong? Matt can tell me what I did wrong. Instead of an equal to sign, what should I have there? No, a little plus, right? Because I'm adding strings together. So now I'm going to run it. All right, I'm going to type in negative 43, 70, 67, and the sum of negative 34 and 67 is 33. You're writing a little calculator. Now it's a little more intuitive. What did I do wrong? This computer's stupid, so I put a little equal to sign there and said, hey, should have a little plus there. So you go back and you tell me. Should be a little plus. It doesn't understand what that is.
let's see. Okay. Line 2. Four.
Go to the next week, click on the tutorials. I got all the small basic stuff here. Yeah. Real easy, loops, for loops, all that other good stuff. That,
Shouldn't be. Oh, let's see what happens. Let's do something.
Fixed window is supplied 3 arguments.
The sum of no one, sum two. Yeah.
We need some fun.
Good word, but I don't know. I see it under the process. But I like it was good word. Good word. Okay. We can continue. All right. Where is it? Oh.
Dr. Maloney.
Yes.
When I tried to run the last one that we just added to, in line 6, it says operation text window right is supplied 5 arguments, but takes 1 argument.
Yes. Okay. Mac had that same problem. It says requires arguments. Now, can you see me here, Caitlin?
Yeah.
I'll kind of highlight this here. What you're having here when it looks for arguments, what are arguments? Basically parameters. And so
Okay.
watch, if I were to get rid of this plus, look what it says. It says it's supplied 2 arguments but takes 1. Basically meaning like, hey, this should really be a plus sign because this is a string that we're adding together. This is a string that we're adding together. And if you don't have anything here, it's going to say, hey, the sum of num1, and you got this and thing here. We don't know if it's 1 or 2 or 5 or 6 or whatever. So between any variable and any string, you want a plus so that we can concatenate the string. Does that make sense?
It does, and I see where I messed up. I didn't have enough addition signs. I only had
You
one
need
on
the addition sign so we can add the strings together.
Okay, perfect.
Add the strings together. Okay, we want to add these strings together here. Okay, that's the big thing that we want to do. All right, now I like this program. We're going to call it Calculator. I can click File, Save, and I can save it wherever I want right here. Okay, I'm going to save it to, I'm going to call it My First Program. And it's going to be stored as something called .sb. It just runs within this little software here. This is about as basic as you can get. Where are you going to save it? Wherever you want it, wherever you can save it, or wherever you want to save it. This is where we want to save it here. Oh, here's a program that I wrote here. Now this gets a little more complex here. What's the first thing I do? I put a little single quote and I say, this is a comment. Meaning now you can start to write to me, hey, Dr. Maroney, this is what I'm thinking. Okay, and there's maybe different ways to do this in Small Basic where you can put the input. So what's the first line say? Enter the distance in feet. Feet equals text window.read number. So you're just going to type in a number in feet. And then meters equals feet divided by 3.28. What am I doing in this program here? Converting feet to meters. And so now feet plus blank feet in meters is equal to meters dot feet. So these are going to be the input parameters based on, I type in 1,000 feet and whatever it is, 300 meters, depends on what you want to do here. So now we're talking about some conversion tools, because when we open up exercise 1, we're gonna have a nice little conversion tool here, where we're gonna convert between Fahrenheit and Celsius, I think. Forget. And we're gonna get more and more and more complex. Ben wants to get into loops, but we're not gonna get into loops yet. You can read on your own and get into the loops and all that other good stuff too. Okay, but for those of us kind of learning this stuff for the first time, I want to make sure we're pretty clear here. Now, this is real basic and intuitive. I work with Python. I might have to convert this thing to a string because we're displaying stuff at the same thing. And it's like, I don't want to work with numbers and strings at the same time. Here, we know what anything in a quote is. That's a string, right? Anything in a quote's a string. They could be your 820 number stored as a string that leads with a 0 as opposed to the ghost zeros or the name of a town or whatever we have there. So we kind of hardwired some of these things and kind of compared it with some other input parameters. Because I want to start kind of opening up the first exercise and see, I think I have you write 3 or 4 different programs. So I want to make sure we can kind of write these and figure these out and get more and more and more complex.
What did you say it was?
I just saved it wherever. Yes. Because I think we're going to start with, we're going to work with some if statements as well here. So now, if we go to our week 1, our week unit number 2, we've got input, output, variables. So I've got introduction videos. These are some really good resources that I've found here. Also down here under small basic tutorials, I've got great tutorials here on variables, conditionals, download practice. So these are some practice things that we can do right here. So what we're going to do here is we're going to open up week 2 materials. I've got tons of videos. I'm not going to sit here and watch videos and go through tutorials on all of our time. I want to kind of start looking at the first exercise and get a little bit more complex here because we've got something called a conditional, which is what we call an if statement. You know, basically meaning, hey, if it's a number, if one thing is larger than the other, then we do one thing as opposed to the first number. And so the first thing that I want to do here is I want to download all the materials in zip file. And just like you did for exercise 1, you're just going to submit all the documents. Did I miss something, Benjamin?
It's week 2, right?
Yeah, week 2. And I want to just open up the materials because I want to start working on the first homework together. And so it's called week 2. I'm going to unzip it. There shouldn't be very much there. Week 2. I've got this program called Hello World. What do you think Hello World does? You open it up and it prints out Hello World. All right, so this is the homework here. We're probably gonna write through the first couple programs, and then I'm gonna kind of leave you for the rest of it, and we'll be done here by 8 or so. So, all right, so we're gonna write a short program. What's that? Yeah. We're not taking a break today, so I don't want to take a break. So my wife's cooking dinner.
Right.
It's really good.
So we can go with you.
An hour away, so we're. So we've got a program here, because what we're gonna use here, we're gonna look at something called if-then statements. Okay, and these are what we call conditionals, like Benjamin alluded to, like, hey, we want to start automating some of these processes here. I think we're gonna talk about that next week. So we're gonna write a short program. We're gonna call it exercise 2, question 1, that asks the user for new numbers, and the output is the greater or higher of 2 numbers. So can you ask for a number? I hope so, because you we already asked for that. Yep, text window, text window dot write, read number. So one of the things that I can do is, do you think you're gonna write that code all over again? No, you're just gonna cut and paste it into something new here. Okay, and you can kind of see here, this was our Fahrenheit to Celsius collector. Now you're starting to see, uh-oh, I got some really nasty stuff here. Look at this. Who wants to learn this stuff? Okay, but we're gonna start with these first couple things here. Okay,
Can I, what am I doing?
I don't,
Every time I close it, it closes my entire.
okay, okay, I'd sign in. Type in your NCC using password. All right, so the first one. We're gonna write a new program here. And I'm just gonna have my small basic here open. Type in a new one here. So what are we gonna do? I'm gonna put in a little comment here. This program is going to ask for 2 numbers and print out the higher of the numbers. Okay, so you notice that's in green, right? That's what we call a comment. And so that just means that, hey, I'm telling you, Dr. M, this is what I'm doing here, just in case you're wondering. So text window dot write, please enter the first number. What do you want to call the first number? What do we call it? Number 1, num1. Right? And we're just working on the first homework problem here. Okay. So this program is going to ask for 2 numbers and print out the higher of the 2 numbers. What are we going to do for the second set of code? Are we going to retype all this? We can just cut and paste it. So we're going to cut and paste it. Okay, and what am I going to ask? I'm going to type, please enter the second number. What are we going to call the variable for the second number? Num2. Now, which one are we going to print out? So what have I done this far? I wrote out a line that says, please type in the first number, and then I input what? Number 1, and then I input number 2. It's only taking 2 inputs. I could take 3 inputs, 10, 50, or whatever I want. And eventually they're gonna get more complex with, hey, I'm gonna take a feature class and do Python stuff to it. So this is gonna be pretty simple here. And you notice what I did before is just type in the distance in meters, and I'm gonna convert it to feet or whatever, vice versa, whatever I did. So this time we're gonna do something called an if-then statement. And if we kind of look over here, and I think I have input string variables, I got some small basic tutorials here, and I can always refer to these under the small basic coding curriculum. And these things are called conditionals. So in small basic, it just tells you a little bit about conditionals. So we have if and then, and the one thing about the different programming languages that they all seem a little bit different. Okay, they all seem just a little bit different. Okay, so we have if, then, else. So we have a statement. This is called a conditional, and then we have some type of action. Yeah, we have some type of action here. Look what I got right here. Ooh, that's pretty cool. So please refer to these tutorials here. Now, what do I want to write on this program? Okay. If what? If num1 is greater than num2, then what? What are you going to do? If num1 is greater than num2, what are you going to say? Yeah. Print. In this case, Python's going to be print. We're just going to do what? Text window. The first number you typed was higher. And if, or I could do something called an else, meaning I got one, I got the other. I can type in the word else. Okay, so if num1 isn't higher, then what's the other option that I have? Num2 is higher, the second one's higher. We're not going to get in the third option. We'll think about that in a second. So the second number you typed is higher. And then with these, type in end if. So I'm just going to refer to this little code right here. I got if, else if, else, because it could be a bunch of different things. Okay, and maybe we'll go back to what happens if the two numbers are equal to each other. Is that what you were thinking, Benjamin?
Mhm.
Is that what you were thinking?
Whoa, this one?
Yeah.
No. That was something else.
Okay. Okay. Because you can see some of these from this code have this. So now what am I going to do? I wrote a little program here. I'm going to read in a number, read in another number. If number 1 is greater than number 2, then I'm going to type the first number you typed is higher. Else, what's the only other thing that could happen? So the second number is higher. We're not going to think about if they're both equal to each other. We'll leave that for another, not time, but just another command. Yeah.
Is might be getting ahead of us, but speaking of third objects, is basic, is it waterfall or object based? You know,
This is object based.
object based.
What's waterfalls?
It waterfall, my dad described it, C++ is apparently.
Okay. That did waterfall back in the day. Yeah, this is all object based with the little points and stuff like that. And it's real, like this is like basic as basic as.
As basic as it gets.
Yes.
Python is also object based.
I think so, yeah. Mhm. So I'm going to run this. Type in the first number, 78, 4. The first number you typed is higher. how do I know this thing works? Just go and run it, right? I'm gonna type in 6 and 6 says is that right though? I typed in 6 and 6 and it says the second one's higher. Why did it say the second one's higher?
That was the second option.
That was the second option. So what do we need to do? We need to create another option, right? All right. So when we look at these commands here, what do we have here? We have if, else if, else if, else if, else. And so what we have here, what we're looking at here, all the different possibilities the value can be. Okay, what are the three possibilities for num1 and num2? First number could be bigger, second number could be bigger, or they're equal to each other. Now, who's gonna be the one to hard code all those in? You, the programmer. So we gotta use else if, you know, what if someone wants to be funny and type the same thing in, okay? Because start thinking about this problem here where we're gonna get real ugly, where you're gonna calculate the quadratic formula. You're gonna type in A, B, and C for the quadratic formula, and C squared equals A squared plus B squared minus all this stuff here, and what's gonna happen there? What happens if you get negative square roots? Yeah, bad things happen. Watch this, yeah, really bad things happen. You know, watch this. Now, text, window, dot, right, you know, SQR, what's square root? SQU? Oh, doesn't know what text window word. It's got math functions in here too, so. My computer's crashing. We'll go back to, uh-oh. Who am I gonna blame? I need someone to blame here. Maybe Cameron, I'll blame him for crashing my computer. I don't know. Uh-oh, that's really bad. Yeah, I didn't even save anything.
You don't put words.
I really want to.
Okay, so. Question 1, hopefully we got the idea of that. We use the if statement, the if then else. So we've got all the different possibilities using the if, else. So 3 different possibilities. Question 2, write a short program that asks the user for the lengths for 2 strings, and the output is that has the greater number of characters. Okay, so use text.getLength. Text.getLength. Oh, that's interesting. And then the input variable. How do I ask for the name of something? Yes.
Wait, are we copying the entire code to the first one? And
From where?
the question one,
Which code? This stuff?
no, like, we just did question one, right?
Yeah.
So are we copying that and pasting it?
You can if you want. Now, what are we gonna be asking for this time? Instead of reading a number, what are we gonna ask for? Read a string, read line. So instead of read number, we've got something here called read, I think it's read line. I'm looking at someone who knows, who remembers off the top of it. There's so many different languages that we've kind of got. And I had to crash my computer here, so. That read. I knew that. All right, read.
Okay, tell me what. See that?
There we go. Okay. So now we're starting to read something instead of reading a number. What are other things that we can read? Strings. In this case, we can read a line. Okay, so we can read this line right here. I got a nice little 5-line program here, and we'll kind of talk about this, and then I'll tie everything up. Okay, so I got this little program here. What's the first thing we do? Text window dot write line says what? Type in a line, please. This is what we call a prompt. So instead of having a little flirt flashing cursor there saying, hey, do what we did on the first program. Next, we have text window dot read. Doesn't have read number. So that we're gonna read text. It could be a number, could be text, it could be whatever. The next thing says write line dot text one. Oh, I don't even need to write that right there. And so what's the very last line say here? So I've got a variable called text1 equals read. What do I do next? The length of the string is what? So now I have a command called text. And so I can't call a variable text because say you're talking about text, text window, get length. What do you think get length does? Count the length of the string, and then it takes in one input parameter. Just like export takes in one feature class or one table, it takes in one parameter. What's that parameter going to be? Text one, whatever you went through the trouble of typing in. Now, do you think you can write a program that takes in 2 texts and figures out what the longer one is and prints it out? Just like you did with the bigger number. But now we're comparing string lengths instead of actual numbers. Like, what's the length of Benjamin Williams versus Tim Mulrooney? Who's got the longer name? All right, so it counts the number of characters, actual characters. Do spaces count as characters?
Yeah.
Okay, so if you put spaces in there, and a lot of times when we start working in data science and you work in Excel and people put in type in stuff and put a space at the end of something, that gets really nasty really quickly because people can't see spaces, but they really exist. So let's see if we can write something like this here so that we can actually get the length of the string, because for exercise number 2, what you're going to do is you're going to compare string lengths. Okay. So I'll give everyone a couple minutes and then we'll talk about those last couple of exercises, because those get really, I don't want to say ugly quickly, but you got to kind of start figuring out some stuff with some math functions and all that other good stuff. Because what have we done thus far? We divided numbers, we added numbers, subtracted numbers. Like, we're gonna start taking the square root of everything. Because remember, what we're gonna do, you're gonna write a program that does the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. Or you can write one that does Pythagorean triples. Pythagorean theorem. Remember that from math? A squared plus b squared equals c squared. Now you'll notice one of the exercises is one of the questions is worth 3 points and the other was worth 4. So which one do you probably want to do? 4 point. So we got a real simple program here. So now exercise 2, let's see if we can kind of just think about this thing real quick. Write a program. We've already done this, right? Write a line. Ask for a text. So you do a write line, a read line. You get some text you type in. You get another text to read in, and then you compare them. You just tell me, use the if-then statement to tell me which one's higher. So we've got an if statement right here. So we've got these if statements right here. And so instead of read number, we can read line. We can compare lengths. You know, I'm kind of anxious to see what we've got here. And these are all just sitting here under the small basic tutorials. So if we click on exercise 2 and small basic tutorials, they're all sitting right here. So please take advantage of these. What we're trying to do right here is just kind of work on exercise 1, 2, 3, 4. You know, we haven't done loops yet. So we're kind of looking at variables and conditionals. Where's conditionals? Number 5. Yep, number 5. So we kind of work on 1 through 5, and then we'll do loops and kind of calculate Pythagorean triples and all this other stuff. Okay? You want to get to the loops, don't you? It's pretty neat. Like, I could do some things that'll like shut this computer down like that when it starts computing. Like, I want to find all Pythagorean triples whose hypotenuse is less than 1,000,000. You know, just like, I'm done. Yeah. You know, just doing it in small basic. You know, it's a pretty neat stuff, because what's a Pythagorean triple? I keep throwing this word around, Pythagorean triple. What is it? What's a Pythagorean triple? Mac, remember Pythagorean triples? Yeah. Remember, Cameron?
Wasn't in your class.
No, okay. Well, from geometry, numbers like 3, 4, and 5. So 3 squared plus 4 squared equals 5 squared. That satisfy a squared plus b squared equals c squared. So if you have a triangle that's 3, 4, 5, that means it's a right triangle. Yep.
Oh, yeah.
Yep. So things like if you have a triangle that has lengths of 2, 3, and 4, it's not a right triangle, because why? It's not a Pythagorean triple. So there's special ones like 5, 12, 13, 6, 8, 10. So where the first one number plus another number, one squared plus another squared equals the other third squared. And you can think about how many calculations you gotta run on something like that. I think hopefully I didn't make them available to you all, but here, if you kind of start digging through digging through some of my resources, you can see some of all that kind of wacky little programs that I've created for this class that don't have anything to do with class, but you can probably utilize and take pieces of and all that other stuff. Cause I think later we're gonna do like a guessing game where it's like, pick a number between 1 and 100 and start typing in numbers and how many times is it gonna do it? Oh, I might guess on the first try, but it might take you 8 passes to do it. And so you start writing little games that do things like that. And so what we're going to do is really focus on exercises 1 through 5. I haven't gone through and reinvented the wheel because Small Basic has created some really neat little programs that kind of do this, allow you to do this. It gets into a little bit of like images and graphics and advanced math. So when we look at variables, if I look at some advanced math right here, you can start to see some of the things. I've got like cosines, radians. Oh, remember all that nasty stuff? Oh, yuck. I don't even want to talk about that. So, ugh. I hate it. I don't even know why they have radians, to be honest with you, but that's another issue in itself. These are different variables here, like area. So we're creating, calculating some of these. So I would just go through, follow some of these tutorials. We've got a lot of things that we've already, some of the things that we've already done, because the third one, what it does is I want to write a program that converts between you input Fahrenheit and you convert it to Celsius and Kelvin. Does anyone know how to convert between Celsius and Kelvin? Hopefully. Well, if you don't, guess what you need to do? Go look it up. How do we convert between those? Okay, remember, please excuse my dear Aunt Sally. And then just make the program, make sure it runs, because when I download this thing, what do you think I'm going to do? I'm going to bring it into this, make sure it runs. I'm going to type in 100. I'm going to make sure I get 37 for one answer, and then I get whatever for the right other answer, 300 and it should be about whatever. It should be about 500 or something like that when I go to Kelvin. So all I'm going to do is just run your program to make sure they work. And then the last one here. And so VB, Small Basic, has some really good utilities for, Small Basic has some really neat utilities for square roots, sines, cosines, tangents. Okay, but if I want to square something, what can I do? Just raise it to the second power, or raise it to the half power as well. So I got a lot of neat things out there that I can do. How's everyone feeling about this exercise? Yes? All right, Dolores, I get an approving yes. I get a begrudging yes from Barbara. That's okay, good. How about Mac? Good, okay. Daisy, Ariel back there. She's just looking the other direction. She's just looking, she's just shaking there. She's just like, now, how about everyone here? How are you all doing? Okay, good. Good. So we're gonna write 4 programs. It's gonna be part art, part kind of science there. But at the end of the day, we want stuff that runs. I think Mac had a really good example where he had a syntax error. That means that it couldn't run because it needed a plus sign when we concatenate strings. In other cases, you're gonna run into things called logical errors, where hey, if you type in a minus instead of a plus and you want to add 2 numbers and you're subtracting them, then the program's going to run, but what's going to happen? It's going to give you the wrong answer. So I implore people to go through, and when you run a program, put in values that you know is going to work. So when we convert between Fahrenheit and Celsius, I know that 98.6 degrees Fahrenheit is equal to 37 degrees Celsius, and then whatever the conversion is between Kelvin. So put in numbers that you know are gonna work. What is it, 373, 437, or something like that for Celsius to Kelvin. Kelvin just goes down to like an absolute zero temperature based on, I think it's 473. Am I right?
I think it's 273.
What she said, 270.
Version of.
Yeah, Celsius,
273, and then the other one is what, 59 something, if you go.
yeah, 5/9 plus minus 32 or something like that. I'll let you all do it because it's too late to do math.
You right about it.
No. And so questions 4, you can do one of the other here. I've provided a resource here for math here, so you could just open this thing up. It's got math resources, so you can do square roots. And then the last one here, you are going to calculate the quadratic formula right there for me. So you're going to take in 3 input parameters. So you're going to type in A, B, C. Remember the quadratic formula from way back in the day? Yeah. Okay, you're going to type in A, B, and C and type those in. You got some weird stuff that can happen here because if that B squared minus 4AC is less than 0, your computer will catch on fire. No, it won't catch on fire. But what happens when you take negative square roots? Really bad things happen. Even when we run these things in ArcGIS Pro, you see some weird things from time to time. That's one of the weird things you have from time to time. So we need to write an if statement that says, hey, if we've got a B squared minus 4AC that's less than 0, let's print out, hey, we're not doing any of that I stuff. We don't do I's in here with the imaginary numbers. You just print out, hey, we don't have any real roots, and we're moving on with our life. Okay, so if you get something like x squared plus 9 equals 0, remember, you try solving x squared plus 9 equals 0. What numbers are going to work? Let's try solving this. Let's go back to algebra class. X squared plus 9 equals 0. What do you do? What do you do here?
So 9, square both sides, then you get x.
X squared equals negative 9. Just take the square root. Take the square root. X equals what?
Technically 3i.
Yeah. Forget we're not doing I's in this class.
Yeah.
Okay. This is just bad. I'll put a little sad face right there, whatever we want to do. Okay. We don't do that. And so it'll just say it doesn't have any real roots because what Mac was getting to is all that imaginary number junk that we're not going to do here. Okay. And so what I want you to do is calculate and to kind of run some if then else statements that run these because we have 3 different possibilities. One possibility is that it's negative and we just print it out and say we have no real roots. The second possibility is that b squared minus 4ac is equal to what? 0. And that means that both of the roots are the same. It's what we call a double root. And then we have a traditional one that we can run where that b squared minus 4ac is a positive number. We add that negative b, divide it all by 2a. Our Aunt Sally with the parentheses and all that other good stuff should be happy about this. And then, you know what I mean, with the order of operations and everything. And so we can set a variable called discriminant. All right, let's go calculate the discriminant before we even get into any of these if-then statements. You're going to be writing a program for me or your nephew or your kids or whoever who they're just going to type in an A, B, and C, and you're going to write a program that gives them the A, well, we give them what X is equal to. That's so nice of you all. They don't have to do algebra again. They skip all of algebra 2, sophomore, or whatever, whenever they take algebra 2. No more algebra 2. You've done it for them. Okay, remember you did all the stupid factoring and all that other stuff? No more. You wrote it for them. Okay, but there's a lot of things you got to think about and a lot of pitfalls you need to avoid. And then also you need to put in some input and some output that someone's going to understand. Please type in the first number. Please type in the second number. Please type in the third number. And then make sure we have some adequate input, output, especially when we integrate these into these if then else statements. And then maybe later we'll get into, what if I type my name in there? Because I noticed a couple of you should try to type it in some junk with the number, and what's it just say? Just gonna call it a 0. So I'll put 0 there. I'll type in Tim plus 56 equals 56. Okay, so with those read numbers, it really restricts your ability to type in anything junky or useless or whatever, and just says anything that's junk, I'm just gonna treat as 0 and calculate as such. All right, I'm done here. I was gonna talk about, I'll mention one last thing here for everyone, because I do like to kind of talk about some skills development and all that other good stuff, which I want to focus on. But if you see any email from me, and if you see any email and you click on forms, I've got a number of different forms up here that have not only forms related to some of the things we're doing, but I've got down here I've got some sample cover letters. So feel free to use like cover letters, promotion cover letters. This is for a student that applied for a couple jobs that we've seen here. So this is a sample job cover letter for a student that I had here. And feel free to use these. This was for a job downtown. There's a student named Corey here, but all of these things in red here are all, these weren't read on his cover letter, but these were all things from the all writing from the job description, because a lot of times when you apply for a job, who looks at your cover letter and resume first? Computer does, right? It's just some computer. And they're going to say, hey, we don't have enough of what we call keyword matching. And so what we did with something like this is we worked really hard to integrate some of the skills that we've learned in class, or kind of force a round peg into a square hole, with making sure we kind of word for word, verbatim, put some of these in there. And so we're really lucky. This student got a job with Durham, City of Durham, where he works to this day. And so I just wanted to kind of point out a couple of those things right there. This was a promotion cover letter, so we applied for a promotion a couple years later. And once again, you can see some of the, I guess I put his name down here, but I didn't erase it up at the top there. But he applied for a promotion here, and you can see some of the cover letters here. So as internship season comes up, feel more than free to utilize some of these here so we can get you a job. Because at the end of the day, like, you know, when you go get a job, you don't get an A, B, C. You get a pass, you get a not pass, you know, and no one cares if you were like the second in line and they really liked you, you know, because what's that going to get you? And that and $5 is going to get you, you know, coffee at Starbucks or whatever, you know, Starbucks costs there. You know, and this student here, he was good, but he wasn't our best student. But he was able to, he had a lot of kind of common sense when it came to what do job people want. Because at the end of the day, there's only going to be one job that cares about what your grades were. What job is that going to be? You're like your first job or your internship, because you apply for your 5th job. Are they going to care that what you got? No, they're not. And so everything's going to build on each other. So that trajectory that you take is really, really important. And this student, Corey, here has been there for about 5 years. He's gotten a couple of promotions right here. And I'm hoping at some point in time, he'll kind of come here and talk about his trajectory working for the, working downtown. He lives down near my parents in Alamance County. He does a lot of work at home. But I posted, and he's given me his permission to post a couple of his cover letters. I don't think I have any resumes up here, but I really want to implore folks to kind of take that next step. You know, I think we recently had a student who kind of came and kind of complained, like, I don't have any jobs. And I'm kind of like, you know, listen, like, you need to be the one to take that step from you getting this to the job portion here, because they interview really poorly, and let's look at your cover letters, and they're really weak cover letters. And like, hey, there's a big disconnect between what's going on in the classroom and what's getting you jobs out there, and make sure you're able to make that healthy and smooth, transition, whether it's how you represent yourself both here, because when you fill these things out, all you're gonna be is just a piece of paper. How do you turn from that piece of paper that people are gonna go back to, again and again and again and again? I'm kind of thinking about that because my wife just got a call. She's got another job. She wants to do management stuff. So she's kind of got another job interview with a company. And I'm like, well, how did you make yourself stand out? I don't know. And it's really qualitative in nature. How do you do it? It's, who or what or whatever there, combined with you really making sure you reinforce the skills that you have. I've got an internship, I've got projects, I've done all these neat things that are really direct for this. So I don't want to sound like your parents, because I know I ignored mine for such a long time. But if you need any help with the cover letters or resumes or getting those together, please let me know. And because you start with here, you get an internship, you might know someone in an internship that you pop up to getting your first job. And, if you're starting at $80,000 on your first job, is your next job gonna be more or less than $80,000? It's gonna be more, and if you start at $50,000, well, you're not jumping from the 50 to the 100, you're gonna have to probably take a couple of steps up there. So make sure you start, doing something that you like, obviously, as well, going up. I swear I'll stop talking like my parents did. All right, so we've got to kind of charge here with some of these programs, and I'll see you all later and have a good day.
So.
You too.
Thank you.
All right, see you later.
Thank you.
All right, see ya. Caitlin, there's Aquila. Hi, Alexis, how's it going?
Obviously, but I didn't-